Okay boys, I'm going to show you how to answer a bounds mixed with trigonometry question. I'm setting you some of these from the book, so I've quickly made up my own version of one of these questions so I can demo it. Alright, this relies on you understanding bounds and how they work when you're dividing things, which we've done in the previous lessons, and also revise a bit of SOCAN, which hopefully you did last lesson. Anyway, I'll take you through this question all the way through, so if there's anything you're unsure about, this hopefully will help you. So we have a right angled triangle, and it says in this diagram the measurements are correct to 3 significant figures. Find the upper and lower bounds for the value of z to 3 decimal places. Okay, right. The first thing to do is to write the error bounds for these two numbers. Okay. We've got 3.62 millimeters, okay, and the error bounds look like those, and we've got 8.41 millimeters. So I'm just setting up right now. Okay, and there's the inequality signs for those. Right, now then, it's been rounded correct to 3 significant figures. So in this first number, 3.62, that is the third significant figure. So it's been rounded to the nearest 0.01. Okay, 0.01. So we need a bound that's 0.01 wide. So we've got to go halfway up and halfway down. Half of this is of course 0.05. Alright, so the top one will be 3.625. Adding this on to 3.62, and the bottom one we'll be taking this off 3.62, which will give us 3.615. Okay, so there's the error bound for 3.62, and I'm going to be using that again for 8.41 because that number was rounded in the same way. Okay, so there's the error bound for 8.41. Right, that hasn't answered question A, but we're well set up for question A. It wants the upper and lower bounds for the value of z to 3 decimal places. Okay, so let's just have a look at that right angled triangle. Z is an angle, and we've got 2 sides of the right angled triangle. So this is SOCAN. When you do SOCAN, of course, you have to identify which sides you've got labelled. Okay, you have not got the hypotenuse, the longest side. You've got the opposite and the adjacent. So within SOCAN, okay, the opposite and the adjacent is the tan thing. Okay, so we're using this thing here, this part of SOCAN, and where it says T, that means tan of Z in this case. A means adjacent, and this means opposite. So what this triangle is representing, as hopefully you know, is tan Z equals opposite divided by adjacent. Okay, so tan Z is going to be the opposite, and then the opposite we've got is 3.62. That's opposite the Z in the triangle, and the adjacent is 8.41. But I'm going to be using these bounds. Okay, so I'm going to try and get the upper bound for this division. So forget the tan for a minute, just think about this division. We're going to be dividing one of these 3.62 numbers, because that's the opposite. I'm going to be dividing one of these two by one of these two. Now if we want this to be as big as possible, we want the biggest thing on the numerator, which will be that one, and the smallest thing on the denominator. So we want 3.625 divided by 8.405. Okay, that's going to give us what I think will be the upper bound, because this is giving us the highest value of the division. Okay, I'll just put a little U there. Well, actually let's not put a U there, let's put UB, upper bound. Okay, I'll work that out in a second. I might as well just set up the lower bound while I'm at it. The lower bound, tan Z, will equal, so remember I'm dividing one of these by one of these. Okay, I can't choose the middle one, I have to choose either the lower bound or the upper bound for 3.62, and similarly for 8.41. but I want to get the lowest possible answer for the division. You'll get the lowest possible answer by dividing the lowest thing by the highest thing. So I want 3 points. Sorry, that's gone off the screen. Hopefully you've not missed out on too much there. 3.615 is the lowest from there, and I want to divide that by the highest from here. 8.415. Okay, excellent. Now then, I can work these two out on a calculator. And how am I going to go from tan z equals a number? I'm going to be inverse tanning the number. So I'm going to be using tan minus 1 on my calculator, and I'm going to be doing that on whatever this division gives me. 8.405. Okay, let's do that now. We need to make sure our calculator is in degree mode, which it is. So I press Shift Tan, the bracket's already been opened, press the fraction button, 3.625 divided by 8.405. Whoops, and then press right and finish off the bracket. Okay, just move that over so you can see it. I get 23.33. Okay, once it's to 3 decimal places. So to 3 decimal places, that'll be 0.30, and that's an angle, so it's degrees. Whoops, there it is. 23.330 degrees. I'm going to move the calculator over here to do the other calculation. So Shift Tan, fraction, 3.615 divided by 8. Rather than divide, 8.415. There it is. Press right and then close the bracket. Press equals. I get 23.248 to 3 decimal places. Think about that rounded to 3 decimal places. You're going to cut it off after that 7, but that's more than 5, so the 7 needs to go up to 8. Okay, and that was supposed to be the lower bound, and that's supposed to be the upper bound, and that is a lower number than that. Alright, so I can write, well actually I've answered it now because I've got the upper and lower bound, but I'm going to write UB here. UB of Z equals LB of Z equals. Let's just put a line down there. These are my calculations for the upper bound. This is my calculation for the lower bound. Alright, that is part A done. There's quite a lot of work for that, but it's all done now, thank goodness. And now we've got to do part B. Write Z to a suitable level of accuracy. Well, if you look at these, let's see what they would both round to. Can you see they would both round to 23 if we rounded them to the nearest whole number? Can you see if we rounded them to 1 decimal place, this one would round to 23.3 and this one would round to 23.2. So they'd round to different things. So I think what we want to do is just use 23 degrees. Okay, because both of those numbers round up to 23 degrees. Okay, but they don't round to 23.3, they don't round to 23.2. Okay, I'm just going to point this out because you might not be quite understanding what I'm doing here. If that 4 there was a 5 or a 6 or a 7 or an 8 or a 9, then this number to 1 decimal place would round to 23.3, and this number to 1 decimal place would round to 23.3. So I would be putting 23.3 degrees as the answer. Okay, you basically want to round these two up to the highest degree of accuracy that gives the same answer, which isn't very much in the case of this question. It's just 23 degrees exactly. Okay, don't worry too much about part B. Okay, it's part A that really I want you to be exploring a little bit more. And the last thing I'll say is this: I've used the words I was supposed to be working out the upper bound, I was supposed to be working out the lower bound. Because you might see in one question, you do a load of work for the upper bound and get a number, you do a load of work for the lower bound and get a number, but there might be the other way round. The one that's supposed to be the lowest one is actually higher than the one that's supposed to be the highest one. So that is probably going to happen, and what you've got to do is realise that and just, you know, switch them over without overthinking it, to be honest. Alright, so just be aware of that. If that happens, don't panic. That might well happen, okay? And you just switch them over so the lower bound becomes the upper bound and the upper bound becomes the lower bound. Okay.